So it was requested that we do a quick supplement for orbital diagrams. I'll walk through a couple of those here in just a second. Anytime we're working with orbital diagrams, we always want to start by writing out a blank orbital diagram. I've drawn out a blank orbital diagram all the way up to 4F. It's not a complete one, but it's good enough for what we'll do with these examples and your homework. Now there are other ways you can draw this out. For example, I'll show you another one right here. This is another example of what an orbital diagram might look like. This one is perfectly acceptable. However, for me personally, the easier one to remember is this one. I'm a much more visual person. It's easier for me to recognize the diagonal lines. So I'll point out a couple of those really quickly. If we draw a diagonal this way, we can get our energy levels. So all of the ones, all of the twos, the threes, the fours, the fives, and so on. And when I'm filling it in, to help me remember what order to fill it in, I actually draw a diagonal line the other way. I start down here and go this way, up to the next one, then to 2P, then to 3P, then to 3D, 4D, and so on. So for me, this is a much more visual and useful way of writing it out. This is the way I personally prefer, but you can choose whichever method works best for you. The element we're going to make an orbital diagram for is Europium, EU. The first thing we're going to need are the pin numbers, the protons, electrons, and neutrons for Europium. Europium is atomic number 63, which tells me it has 63 protons. Because it's neutral and I haven't shown a charge, the electrons will be the same. The mass number for Europium is 152. So to get neutrons, I take 152, the mass number, and subtract out the atomic number of 63, and I'll get 89. When I'm filling in an orbital diagram, I need to make sure that I'm using the electrons. Electrons are what go in an orbital diagram, so I'm going to track how many electrons I've used over here. I'm going to keep track right there of how many electrons I've filled in on the diagram. When I'm filling in the diagram, I always start at the lowest energy, or the bottom of the diagram, and work my way up. Because I've drawn it out like this, I know that the diagonal lines are the order that I fill it in. So my first orbital that I fill in is 1s. So I fill in my first electron with a half arrow pointing up. The second electron is a half arrow pointing down. So that orbital is now full. Each line can have an upspin and a downspin. So I have 61 electrons left to place. I go up to my next orbital and fill it in. I have 59 electrons left to place. My next orbital is the 2p orbital. I have 59 left to place. It can hold 2 in each line, or a maximum of 6. I have more than enough to fill it. When I fill an orbital, I fill all of the upspin electrons first. I fill all of the upspin electrons, and then I go back down and pair them up. So now I have 53 electrons left to place. Following my diagonal line, that takes me to the 3s. That leaves me with 51 electrons left to place. Now I start my new diagonal right here at the 3p. I fill my way up. I've got plenty of electrons, so I can keep filling it up. I still have 9 electrons that need to be placed. My next orbital is the 6s, which can hold 2. I can go ahead and fill it up. That leaves me with 7 electrons to place. My next orbital is the 4f orbital. It has 7 possible orientations, so it can hold 14. I don't have enough electrons to fill it up, so I can only put in it what I have left. So I can only put 7 more electrons in. Remembering that I fill the up spins first, I filled in all 7 electrons, and I don't have any left to go back and pair. So this is the orbital diagram for Europium. There may be times that you're asked to find the orbital diagram. There may be times that you're asked to find the orbital notation. The orbital notation comes from our orbital diagram. It's just a written out version of it rather than a drawn version. For orbital notation, we still put these in order, so we follow the same order. I write the orbital, so my first orbital is 1s. And then I use a superscript to fill in how many electrons are in the 1s orbital. So I've put 2 electrons in. I use a superscript for 2. I go to my next orbital, which is 2s. I've put 2 electrons in it. So it is 2s2. My next orbital is 2p. I've put 6 electrons in it. And I continue so on and so forth. Orbital, how many electrons? Orbital, how many electrons? Okay, so I fill it in, more of the notation. I've gotten up to 5p. I still have 2 orbitals left to place. I have the 6s, which has 2 electrons. And lastly, I have the 4f orbital. And it has 7 electrons. So our orbital notation is given here. And we read it just like we would anything else. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f7. So this is the orbital notation or the electron configuration for Europium. Hopefully this gives you some help for your homework. If you have any questions, feel free to message or email me. I will get back to you as quick as I can. Thank you.